A fully reusable stainless steel booster rolls to testing, and it's not the one you're thinking of. But SpaceX is also getting Starship ready for Flight 12. Meanwhile, NASA gets ready to give one of its old spacecraft a new lease on life, and Curiosity got stuck on Mars? As always, we've got all that and more coming up this week in Spaceflight. A brand new stainless steel first stage for a reusable rocket has left the factory. And no, I'm not talking about another super heavy rollout in Starbase, though we will have some Starship news in just a bit. But let's take a look at that other rocket first, shall we? I am of course talking about Stoke Space's Nova. Stoke has been working on this rocket for quite a while now, and it's getting ever closer to its first launch. Nova is built to be fully reusable and is made out of stainless steel. Its first stage is powered by liquid oxygen and liquid natural gas, or methane, and its Zenith engines run the full flow staged combustion cycle, just like SpaceX's Raptor. Just looking at that, it seems that squinting at the spec sheet might confuse some Starship fans, but the two rockets aren't really similar in any other way. First of all, there's the size. The gargantuan Starship Super Heavy combo dwarfs the medium lift Nova, which can lift up to 3 metric tons to low Earth orbit in its fully reusable configuration. Stoke's first stage is pushed by 7 Zenith engines, compared to the 33 Raptors on Super Heavy. The differences become obvious when we tilt our view up to the second stage. Nova's reusable upper stage is nothing like Starship. Instead of methane, it's fueled with liquid hydrogen, and it only has a singular engine called Andromeda. It might not look like it because Andromeda has 24 individual thrusters, but it shares turbo machinery, so it's technically considered to be a single engine. And it's one that doubles up as a heat shield too. Instead of using conventional heat shield tiles, Stoke's metallic heat shield is integrated into the engine and actively cooled with liquid hydrogen the way that rocket engines are cooled. This heat shield engine combo will protect the stage during re-entry, then light up to slow down the stage for a propulsive landing. Where Nova does share another similarity with Starship is its staging strategy. Andromeda's thrusters are positioned so that they stick out and fire alongside the first stage. This allows for hot staging, or igniting the upper stage while the lower one is still firing, which is a far more efficient strategy than regular staging. Starship uses it for the same reason. So how's Nova coming along? Well, Stoke has regularly been dropping videos of engine tests and photos of manufactured rocket parts. We even got a view inside the booster last week. But now, we finally got to see something big. A mostly completed first stage for the first flight. The booster, named SN1, left Stoke's factory in Kent, Washington, to move across the state to the company's test facilities in Moses Lake, where it was lifted onto a test stand. CEO Andy Lapsa said that it took the company only 18 hours to get the booster off the factory floor and mounted onto the stand, hinting that he wants to get that time down even further for future vehicles. Next, engineers will put the stage through its paces on the test stand for a process called proto-qualification. This verifies that the flight unit meets all qualification requirements and is free of manufacturing defects. If it passes the test, next the boosters will only need to pass acceptance testing. After passing scrutiny at Moses Lake, SN1 will move back to the factory to get all the final parts installed to make it a functional rocket, after which it'll be sent off to Florida. Cape Canaveral's Launch Complex 14 has seemingly been sitting ready for a few months now, after Stoke gave it a complete makeover to support Nova launches. If all goes well, it should see its very first later this year. We'll keep our eyes on this rocket and let you know when it does something worth tuning into. And if you want to stay on top of those updates, you know what to do. Like this episode and subscribe to our channel so you won't miss a thing. There's a lot to look forward to. NASA has outlined the plans for next year's Artemis III mission, with some new details emerging. 4 astronauts, yet to be announced, will spend longer aboard Orion than during Artemis II. The mission will test the life support systems even further, and for the first time, will demonstrate its docking capabilities. Now, ideally, NASA will test out both the Blue Moon and Starship HLS lander designs. It's been working with both Blue Origin and SpaceX to define the concept of operations for the mission, which will operate in low Earth orbit to afford the pair more launch opportunities. The mission will test rendezvous and docking, with astronauts potentially entering at least one of the landers. They'll also get to evaluate lander interfaces for Axiom Space's AX-EMU spacesuit ahead of surface operations on the following mission, and test other critical systems. The mission is analogous to Apollo 9, proving that the lunar architecture works before committing astronauts to the real thing, and in the process, de-risking the Artemis IV first landing attempt. Artemis III will also test the agency's upgraded heat shield design during Orion's return to Earth, enabling it to use more flexible re-entry profiles on future missions. But there's one piece of hardware that they're leaving on the ground, and that's the Interim Cryogenic Propulsion Stage, or ICPS. Now, this is critical to raise Orion into a high Earth orbit that will prepare it for the lunar injection burn towards the moon, but it's not needed for this mission, and NASA has only one of them left. The agency had originally planned to transition to the larger Exploration upper stage for later missions, but now plans to use a Centaur upper stage in its place. The ICPS will be kept back for Artemis IV, which plans to deliver astronauts back to the lunar surface in 2028. In its place, a dummy upper stage that NASA refers to as a spacer will look and weigh the same as the upper stage, but it won't contain any engines or propellant systems. This will preserve SLS's geometry, keeping Orion in the same position on the stack and allowing existing hardware interfaces to remain largely unchanged. The spacer is currently being fabricated at the agency's Marshall Spaceflight Center in Huntsville, Alabama, with barrel sections and rings being machined for welding. Meanwhile, the Orion service module for this mission is heading into acoustic testing at NASA's Kennedy Space Center Operations and Checkout Facility. The SLS core stage is currently in High Bay 2 of Kennedy's Vehicle Assembly Building and was attached to its engine section earlier this week. As we reported in the last episode, NASA won't be using the Deep Space Network for the mission and is instead seeking input from industry on communication relay solutions. It's also now seeking domestic and international interest in potentially deploying CubeSats into orbit during the mission. The concept of operations is still being defined, but it's great to see Artemis III taking shape as we work towards this pivotal test flight. While we're on the subject of the moon, commercial space robotics company Lunar Outpost revealed its Pegasus LTV, or Lunar Terrain Vehicle, this week. Named after the winged horse in Greek mythology, Pegasus is designed to operate on the lunar surface for at least a year and can travel more than 900 kilometers. That is 100 times the distance that the Apollo rovers were able to cover across the entire program. As the company's name suggests, Lunar Outpost has its focus firmly fixed on driving the Artemis program towards establishing a moon base. Full details aren't public yet, but the design features deployable solar panels and will carry 2 astronauts in an open-air rover configuration rather than in a pressurized habitat. Unlike the Apollo rovers that it resembles, NASA's brief wants the LTV to also operate autonomously without astronauts on board. It would be controlled either from Earth or via other lunar assets, allowing it to perform scouting missions, for example. Pegasus is one of 3 commercially developed rover designs selected by NASA in April of 2024, and is a pared-down and simplified version of the company's larger Eagle LTV. The selections also included designs from Intuitive Machines and Venturi Astrolab. The agency recently completed a first round of testing of ground test units for all 3 designs in February at the Johnson Space Center in Houston. Now, Lunar Outpost has already sent a rover to the moon, but it didn't get to drive across the lunar surface as planned. The company's Mach rover touched down in the South Polar region in early March 2025 aboard Intuitive Machines' IM-2 Athena lander. Technically, it became the first commercial rover delivered to the moon, but when the lander ended up on its side after touchdown, the rover wasn't able to deploy. A second Mach rover will ride aboard the IM-3 mission, which is currently targeting the last quarter of this year. From the moon, we go to Mars and its current and future robotic explorers. NASA's Curiosity rover recently got itself into quite a predicament. In late April, the rover tried to drill into a rock named Atacama to collect a sample, and it got stuck. As the rover lifted its robotic arm, all 13 kilograms of rock came with it, stuck to the drill bit. That's not how things were supposed to go, and it had never happened before. Curiosity couldn't continue exploring Mars this way, so NASA had to find a way to rid the rover of the rock. This proved harder than expected, and the rock remained attached for a few days. Finally, in early May, engineers managed to spin and vibrate the drill just enough for the rock to come loose, shattering as it fell to the ground. Now freed, Curiosity can continue to explore the Martian surface and hopefully find some less clingy subjects to study. Meanwhile, Curiosity's younger sibling Perseverance took a new selfie. It actually did so on March 11th, but NASA just shared the image with the world. Besides the rover, it also shows a rocky outcrop named Aretusa, which Percy had previously studied, as evidenced by the bright circular abrasion patch left on the rock. But how does a Mars rover take a selfie like this? It uses a camera named Watson, meant for taking close-up pictures for science. It doesn't have the wide field of view to take a picture of the rover all at once, but fortunately, Watson is attached to Percy's robotic arm, which can move it around and take multiple pictures that stitch together into a complete view of the rover and its surroundings. The arm itself disappears from the image as it's moving around between shots, out of the way of the individual frames. It's kind of like Percy has one of those invisible selfie sticks used for 360 cameras, just a whole lot more complicated. In a few years, Percy and Curiosity will hopefully get some company in the form of the European Space Agency's Rosalind Franklin rover, which will explore the Martian surface and drill into it, searching for evidence of past life. This week, prime contractor Nayuta Space completed an important milestone for getting the rover off of our home planet. They completed the structural models for the spacecraft and the lander that will carry Rosalind Franklin to the Red Planet. These test models are meant to be representative of the space hardware that will eventually make its way to Mars. Every part of the mission is modeled, including the rover, the entry, descent, and landing module, as well as the spacecraft that'll take care of the journey to Mars. During a series of tests, these models will verify that the actual space hardware can handle whatever launch and space will throw at them. First, they'll undergo vibration and acoustic testing to mimic the launch environment. Then, the hardware will be subjected to shock and separation tests and other structural testing. This helps engineers to verify that the spacecraft will survive the most intense conditions that it'll encounter on its way to Mars. Once that's done, they'll move on to the actual flight hardware, which will have to prove itself during its own test campaign, including not only vibration and acoustic testing, but also thermal vacuum and electromagnetic compatibility testing. With all of these tests complete, the spacecraft will finally be ready to move to Florida ahead of its launch atop a Falcon Heavy in 2028. NASA's working on another mission concept that will explore the Red Planet from the air. Following in the footsteps of Percy's helicopter friend named Ingenuity, NASA wants to send more flying explorers to the Red Planet. Launching as soon as December of 2028, the Skyfall mission will deliver 3 helicopters to Mars on a nuclear-powered spacecraft called SR-1 Freedom. One of the challenges for these missions is the thin Martian atmosphere, which requires the rotor blades to spin very fast to get the helicopter airborne. In certain conditions, that might lead to the rotor tips spinning faster than the speed of sound. Ingenuity's teams avoided these conditions at all cost because they didn't know if the blades could handle that. But they wanted to be sure for future missions. So, NASA used JPL's 25-foot space simulator chamber to perform 137 test runs in a simulated Martian atmosphere, spinning rotors until its tips reached supersonic speeds, all the way up to Mach 1.08. The engineers are still working through the data, but so far it seems to have been successful as they managed to push the rotor farther than expected. Tests like these will allow NASA to operate its future helicopters with much more confidence and get these cool missions off the ground. Katalyst Space Technologies has completed environmental testing of a robotic servicing spacecraft that NASA hopes will save its Swift Observatory from orbital decay. The clock has been ticking on this project since last summer when the agency identified the need to conduct an orbital raising rescue for the Neil Gehrels Swift Observatory. With no onboard propulsion to perform its own orbital station keeping, the observatory had fallen significantly in altitude from around 600 to 400 kilometers. Increased solar activity intensified the atmospheric drag, and Swift was expected to enter Earth's atmosphere towards the end of this year without intervention. NASA temporarily suspended most of its science operations in February to buy some time and keep Swift oriented to reduce that drag and slow its orbital decay. Swift was launched in 2004 on what was originally a 2-year mission, using 3 telescopes to study gamma-ray bursts. The observatory has since over-delivered, remaining in orbit for 21 years. But the agency wasn't ready to give up on it just yet. NASA began soliciting industry concepts for the rescue mission and formally announced that a $30 million contract had been awarded to Arizona-based Katalyst at the end of September. Described by NASA as a high-risk, high-reward mission, a modified version of Katalyst's Link servicing spacecraft will need to rendezvous with Swift and boost its orbit, but it has less than a year to do it, and that includes designing, building, testing, and launching its solution. Just 8 months later, Katalyst has made significant progress, and last week it completed environmental testing of the Link spacecraft at NASA's Goddard Space Flight Center in Greenbelt, Maryland. The craft underwent vibration testing to simulate the intensity of launch, and thermal vacuum testing to expose it to the extreme hot and cold temperatures that Link will experience in space. They also tested Link's 3 ion thrusters and one of its 3 robotic arms. Swift has no docking port, so these arms will instead be used to grapple flanges on its launch adapter structure. Link will next be integrated with a Northrop Grumman Pegasus XL rocket at NASA's Wallops facility in Virginia. The Pegasus will then be carried by Stargazer, the last airworthy Lockheed L-1011 TriStar in service. The mission is reported to be on track for a launch in June. Here's hoping it arrives in time to give Swift the boost that it urgently needs. Now we'll take a look at some other stories across space, starting with SpaceX, which is getting ready for Starship's next test flight. Flight 12 will introduce a myriad of upgrades from the rocket to the launch pad. It'll be the first flight of the Starship and Super Heavy version 3 hardware, and it'll lift off from a brand new launch pad purpose-built to support the rocket's new version. Throughout the last few months, we've seen Booster 19 and Ship 39 prepare individually, going through cryo tests, static fires, and many other tests. On May 7th, Booster 19 performed a full-thrust static fire with all 33 of its engines, lasting about a minute. The test was followed a couple days later by the first full stack of the 2 stages, which then performed a wet dress rehearsal with a flight-like countdown on May 11th. This was followed by some last-minute ship testing today at their Massey's test site. SpaceX's first opportunity to launch Flight 12 is on May 19th, but of course there's always a chance that it could slip. Here's what to expect whenever it launches. Booster 19 will perform a normal mission, except it won't be recovered. Instead of returning to the launch site, it'll perform a landing burn for a splashdown in the Gulf. Meanwhile, Ship 39 will continue on its way to space, where it'll deploy 22 Starlink simulators. The last 2 will carry cameras to take images of Starship's heat shield, so that SpaceX can test methods of analyzing it and its readiness for re-entry. They're also planning to relight a single Raptor engine while in space. Like previous flights, this one will follow an almost but not quite orbital trajectory. Hopefully this will all go well and end with Starship landing on target. Now there's a lot riding on this mission. Starship's previous version wasn't nearly as reliable as SpaceX had hoped, and this one is supposed to fix all of its issues. But if it does, it'll put SpaceX on a good track to get Starship operational to eventually support the Artemis program with Starship's HLS Moonlander version. Fingers crossed. On the political side of spaceflight, the House Appropriations Committee approved its full budget request for NASA. The request counters the presidential budget request for fiscal year 2027, which proposed cutting the agency's total budget by 23%. To make it happen, they proposed massive cuts across NASA's programs, including a 46% cut for science. The new bill intends to restore most of it, though not completely. Science will still receive a cut, but much less than the administration wanted. A few highlights of this new budget request include support for the Skyfall Mars mission that we discussed earlier, as well as the SR-1 Freedom nuclear-powered spacecraft to get it there. It also sees continued support for NASA's space telescopes, including the Chandra X-ray Observatory, which has been the target of several cancellation attempts in recent years. However, the Lunar Gateway space station seems well and truly dead. The request doesn't try to resurrect it, and instead focuses on a moon base. One peculiar addition is a recommendation to allocate $5 million for modifying a U.S. cargo spacecraft to land crew on a runway. Now that certainly sounds like Dream Chaser, which has been struggling to get off the ground. $5 million isn't much for a spaceflight program though, let alone one involving crew. Now of course this bill still has a long way to go before making it into law, but it seems that Congress doesn't want to run with the massive cuts that the administration had in mind. So we'll keep you posted. Next, we move to China, where Beijing-based Nayuta Space has revealed the novel way that it plans to land its reusable booster. As China moves towards reusability, we've seen plans over recent months of how different launch providers intend to land their hardware using drone ships, Starship-like catch towers, and even a cable net system at sea. This one, however, takes an unusual turn. Nayuta Space intends to land its Blackbird R boosters horizontally in what you might call the belly flop. The company originally planned to catch the booster using a Starship-like catch tower, but then pivoted to this approach last August, which it calls the Aerodynamic Deceleration Horizontal Landing, or ADHL method. The approach removes the dependency on specialized recovery hardware, optimizing propellant use and increasing payload margins, according to the company. In the last moments of flight, 3 of its 13 engines will fire to cancel out the vertical and horizontal velocity. The vehicle will then rotate and use 6 smaller thrusters along the booster to complete complete the landing in this bellyflop-like orientation. The Blackbird R will stand 70 meters tall and 3.8 meters in diameter, making it similar in size and thrust to the Falcon 9, though it will burn liquid methane and liquid oxygen for propellants. The company has been testing the control surfaces of its test article and recently raised additional funding to continue development and testing, targeting a maiden flight early next year. We'll definitely be keeping an eye on this story and whether this approach really can stick the landing. This is your weekly space traffic report provided by Spaceflight. Starting off the week on May 11th, a Chang'e 7 lifted off from China's Wenchang spaceport, carrying the Tianzhou 10 cargo spacecraft into orbit. The space freighter docked with the Tiangong space station a few hours later, delivering over 6 tons of food, water, instruments, spare parts, propellant, and other supplies. The next day, a Chang'e 6A launched from Taiwan, carrying a batch of internet satellites for China's Qianfan constellation, also known as Space Sail or G60. Later in the week, Zhuche 2E returned to flight carrying an inert mass into a polar orbit. This was the rocket's first flight since its launched failure in August of last year, during which an electrical fault cut the second stage flight short. In addition to fixing the issue, Landspace also used this week's flight to introduce several rocket upgrades, including a stretched first stage. Next, a Lijian 1, also known as Kinetica 1, lifted off from Zhochuan, carrying 5 payloads into orbit. Over in space, NASA's Psyche spacecraft swung by Mars for a so-called gravity assist. Flying just 4,500 kilometers from the red planet's surface, the spacecraft will use the planet's gravity to speed up and adjust its trajectory. The gravitational boost will help the robotic explorer catch up with asteroid Psyche, where it's scheduled to arrive in 2029. Mission teams use the Mars flyby to train Psyche's instruments on the planet, not just to send home some pictures, but more importantly to calibrate the spacecraft's sensors and practice operations so that they're ready for prime time when Psyche arrives at its destination in just a few years. Of course, SpaceX also launched a few times this week. First, Falcon 9 lofted a batch of Starshield satellites for the U.S. National Reconnaissance Office's proliferated architecture. The mission was conducted from SpaceX's pad at Vandenberg Space Force Base in California. SpaceX also planned to launch a cargo Dragon to the International Space Station this week, but it was delayed a few times due to weather. Another launch opportunity was planned for just before this episode aired, so it might have gone up by now, and we'll let you know what happened next week. Dragon will arrive at the ISS on May 17th to deliver food, supplies, and equipment. Later in the week, SpaceX is set to launch 9 communications satellites for Globalstar, lifting off from Cape Canaveral. The company is also planning 2 Starlink missions, one from either coast. But SpaceX's main event next week might be Starship's 12th flight, which we discussed in detail earlier. We'll also get a European launch next week, as Vega C will launch the SMILE mission from Europe's spaceport in French Guiana. SMILE, short for Solar Wind Magnetosphere Ionosphere Link Explorer, is a collaboration between ESA and the Chinese Academy of Sciences to study how solar wind interacts with our planet's magnetosphere. Meanwhile, China plans to launch a Chang'e 8 from the commercial site of Wenchang, carrying more Qianfan internet satellites into orbit. Later in the week, South Korea's Agency for Defense Development plans to launch a demo mission of its military smallsat launcher. The solid-fueled rocket already flew a few suborbital missions a few years ago, and it even delivered a payload into orbit on a later flight, but that one didn't have a second stage. This week, they plan to test the full configuration on an orbital mission for the first time, lifting off from an offshore platform near Jeju Island. Over in New Zealand, Rocket Lab plans to launch another Electron on a mission named Viva La Strix. From that name, you might have guessed that this is another launch for Japan's Synspective, and that would be correct. Closing out the week, ULA is set to launch another Atlas V in its most powerful configuration, delivering another batch of internet satellites to space for Amazon's Leo constellation. And that should be it, but the schedule could of course change throughout the week, so keep your eye on the Spaceflight app and website for the latest updates. And that's your weekly update of spaceflight news. I'm Alicia Siegel for NSF, and we'll see you all again next week to recap this week in spaceflight.